a lot of it's art. You know, you just, it isn't a fixed way that you approach it. You just look at it and kind of figure out. So I'm on page 284, and I'm going to do, well, let's look at some of those concept check things. It says, suppose you are solving, number one, a trig equation for the solutions over the interval from 0 to 2 pi, and your work leads you to 2x equals 2 pi over 3, 2 pi, and 8 pi over 3. What are the corresponding values of x? What,
I don't even understand the question.
well, what it is, see, they're saying that what you get, you have found that 2x equals 2 pi over 3, 2 pi, and 8 pi over 3. Once you see it, it's easy. You just take 1/2 of both sides. It's like, treat it like an equation. X is going to equal pi over 3, right? See, this is what I'm doing. I'm doing 1/2 here, and then I'm doing 1/2 of each one of these things.
Trying to break them down again, like
Yeah,
6-2.
yeah.
Oh, but yeah.
See, what you probably used is you found the cosine of 2x was going to be equal to 2 pi over 3, probably a negative square root of 3 over 2. And that would be 2 pi over 3, right? And then maybe something else gave you the 2 pi and this. Well, once you get this, that was 2x. So now to find out what x is, you take 1/2 of each one of those. So your answers are, right? You see, it's pretty simple once you. And the next one is not bad either. Suppose you are solving trig equation for solutions over the interval from 0 to 2 pi, and what you found is that 1/2 x equals pi over 16, 5 pi over 12, 5 pi over 8. So what are you going to have to do? Multiply 2 times all times 2.
So why is it so easy right there? And then in 5 seconds I'll be so confused.
No,
I'll
Yeah.
never know the name anymore.
It's
Well-
wait till you get home, you take your homework out, you lay it on there.
And it's like, what?
But you see when it's 1/2, you multiply every one of those answers by 2, right?
Right, to get
Yeah.
the x separate.
Yeah.
Get x
And see, the next one says, what happens when you get a solution that says 3 pi equals 180, whatever those
divide them
things.
all by 3.
You divide them all by 3. Yeah.
Okay, so yes, can we just have all of those be on our test and just that?
Okay. All right. So
Theta equals angles and x or t.
now this first problem is kind of going to be related to that. I'm going to do 12, and it says the cotangent of 3x equals the square root of 3. Now, this has got to be an inverse function, and we don't have inverses on cotangent. So what we have to do is we got to do 1 over the tangent of 3x equals square root of 3 over 1, and then tangent 3x equals 1 over the square root of 3. Now you can do this. 3x then is going to be the tangent inverse of 1 over the square root of 3. Now, where is the tangent of an angle equal to 1 over the square root of 3? Well, it's a place where it's a positive, and you have the cosine is the square root of 3 over 2, right? So it's in the first quadrant. It's going to be what? Pi, is it pi over 6?
60, 5 or 6.
60 or pi over 6? See, and it says in the interval from 0 to 2 pi. You see the instructions, solve each equation for exact solutions in the interval from 0 to 2 pi. So then this 3x is going to be, the first place that it exists is pi over 3. Is that right? Because, see, this is sine over cosine, and the only way you can get the denominator to be square root of 3 is that it has to be square root of 3 over 2. Cosine would have to be, right?
Oh, yeah, square root of 3, that's square root of 3 over 3.
3 over 2.
And that's not, that's at pi, is that pi over 6 or pi over 3?
5 over 6.
5 over 6.
Okay.
Yeah,
Confusing you?
Yes.
So it's pi over 6.
1 over the square root of 3 is equal to square root of
Now,
3.
when,
Yeah, that's where you have to be square root of 3 over 2, and I'm like,
okay,
we're gonna
now,
go horribly wrong.
tangent is always 180 degrees or pi units apart, correct?
Yeah.
So you take, yeah, tangent is always pi units apart because it goes every pi, right? It makes that little deal. So it's going to be the same values every pi. Remember that? Am I talking in, see, if you go
Yeah.
a vertical, if you go vertical
Every 180 degrees is going to be the same answer.
yeah, see, because at pi over 2, minus pi over 2, pi over 2, then you go over here,
Yeah, 35 0 is the same answer.
Yeah.
20.
yeah, because it goes just like this,
10.
yeah, then it goes just like this, and from here to here, it's a pi. So every one of those things are pi apart, right?
For tangent, everything's
So-
180 degrees across.
Yeah.
everything tangent.
So what you do is you add pi to this, which is, pi is 6 pi over 6, right?
7 pi over 6.
So then the next one, that's what I'm getting to, is then it's 7 pi over 6. Now I have to do it enough to get 0 to 2 pi.
Oh, we got to find those.
When, see, x is going to be between 0 and 2 pi. So now when I divide this, see, I'm going to have to divide each one of these by 3. And then when I divide it by 3, I got to get enough of them to get it between 0 and 2 pi.
So 5 over 2, 5 over
Then the next one up here would be another 6, so this would be 13 pi over 6, right? And then another 6, 19 pi over 6.
we're going to
When I divide by 3, I gotta go between here and here.
3 times.
So, when I get the x, see, this is going to be pi over 18, right? And this is going to be 7 pi over 18. This is going to be 13 pi over 18. And this is going to be 19 pi over 18. So I'm just slightly beyond pi, right? And I got to go out to 2 pi. Right. So I've got to go on with this one.
All the end answers have to be.
See, this has to be from 0 to 2 pi.
End answers. I thought
Yep.
just the first.
No.
Oh,
See, so then the next one up is 25 pi. 25 pi over 6. I'm just keeping adding 6, right? 6 pi over 6. Then it's 31 pi over 6.
on the wheel, you got to go around 3 times.
Mhm.
Because 0 to 2 pi, 3 times.
See, and if I do this one's going to be 25 pi over 18, and then 31 pi over 18. See, and if I go 6 more here, I'd be beyond 2 pi here, right? See, 2 pi would be 36 pi over 18, right?
Yeah.
So if I added 6 here more, I'd be 37 pi, and that would be too far.
Right. Since it's 0 to 2 pi,
Now, do you see this set right here has got to be between that.
right,
Then you gotta make this set long enough so that when you divide by 3, this one is between 0 and 2 pi.
so more or less what he's telling you is 3x, you got 0 to 2 pi. You're gonna have to go find the numbers around
Yeah.
that 3 times. 'Cause 2
Yeah.
pi is 1 circle, so you're gonna have to go 3 circles to find
Yeah.
the numbers, then divide by 3 and
Yeah.
then all fit in.
Yeah.
So you're dealing with 3x's, not just 1x.
Mm-hmm. Do you see it,
You
Lillian?
gotta go 6 pi.
I think it's gonna be another problem.
See, this right here, from 0 to 2 pi, tells you the values that you have to get here. See, 0 is less than pi over 18, and 2 pi is greater than 31 pi over 18. If I went another one up here to 37 pi, I'd have 37 pi over 18, and that would be beyond 2 pi,
Right.
because 36 pi over 18 is 2 pi.
So technically, what he's saying is from 0 to 2 pi.
I'm asking Lily, you understand it? Lily, do you understand it? Okay. Are you good, Brad? Okay.
There's more.
You gotta find
But
the
it-
answers after you divide.
Yeah.
So to find the beginning answers before you divide them, you're gonna need 3 circles, because you're 0 to 2. You gotta find the answers all divided by 3. There's 2 tangents that are the exact same, that 3 pi over 3. If you circle, you wanna find it divided by 3 in that circle. So you're gonna have to find 3 circles with numbers, divide them by 3, and they'll all fit in the first circle.
Okay.
Draw me a picture.
It makes sense
He
to
did.
me, but when I go to do it, I'll be like, how do we do this? That's what I was at. I understand it now, but I go study at that same time.
Well, it's just your end result down here on X has got to be everything between 0 and 2 pi.
If you divide,
Then you just got to go with the 3x far enough until you get the values when you divide 3 into it.
what
Because-
values you gotta find?
It's less.
Yeah.
You divide 0, you gotta.
It makes perfect sense looking
Right,
at it,
right.
but as soon as I attempt to do it, I'll be like,
Yeah.
how did what?
Same way.
Huh?
I'm still
This is
going,
what I do in TechCom instead of listening to speeches. Yeah. Debbie sits next to me and it's in that different one.
Okay. Okay. Now this thing right here, what you're going to have to use is an identity to convert it to something cosine. So what in your identity is cosine 2x?
take out a cosine. No,
No, look at your identities. And what is the identity that converts cosine 2x to something cosine x?
And one's bigger.
It's the cosine.
Look at your identity.
Square.
double angle identity?
Yeah, something like
Where's the cosine 2? Where's the 2x?
right there.
I can't see that.
Very top of file. Next time.
Yeah. Okay.
Double angle. We use that one.
Yeah, cosine, see, the cosine 2x, I would use this one right here. See this cosine?
This one.
I'd use that.
Which one?
The
Use on,
cosine 2a.
on page
Cosine squared a
251.
minus 1.
you see if you use, what is that? Is that cosine squared x minus 1?
Yes.
See, if I use the identity that cosine squared x minus 1. See, that cosine 2x is that, right? That's one substitution I can make. See, now what I have is everything is in cosine x, right?
So we take out.
2 cos, wait.
The identity says that this thing right here
Yes.
is this.
It says it's 2 cosine squared x minus 1.
2,
Yeah.
put a 2 in here, okay, all right.
So I can't remember the.
Oh, yeah,
Yeah.
okay, we're just changing one half.
Yep.
I was like,
This is what you substitute for this. Now what you want to do is write this, see, this is a second degree polynomial.
now we're.
Write it in descending order. No, write it in descending order. 2 cosine squared x minus cosine x minus 1 equals 0. So that is a second degree polynomial in 3 terms. You can factor that, can't you?
Yeah.
And see, you got 0 by itself on one side. So then what is this going to be? This is going to be 2 cosine x, and then you're going to have a plus 1 here, right? Cosine x minus 1.
Now we're at 2 answers.
Yeah, but you see how it factors?
Yeah.
I mean, that's what you got to be able to see.
Yeah. You gotta be able to change part of it to get it into those
Yeah.
factors.
So what you got to, anytime you see something that looks like it's an identity, then you want to try to,
Switch it.
yeah, substitute it.
You gotta-
Now then, you take each one of these and set them equal to 0. 2 cosine x plus 1 equals 0, or cosine x minus 1 equals 0. And then solve this, get cosine x by itself. Take this over as a minus 1 and then divide by 2. Now, notice that what they're wanting to do is they're wanting us to have it on the interval from 0 to 2 pi, not including 2 pi. So cosine is equal to a negative 1/2 in that interval where?
I'm good to right there. Now I'm like, wait, what?
Well,
Negative
just,
1/2 is in the second quarter.
I either write them down and not pay attention.
is
try
it
to figure out later.
2 pi over 3?
Pay attention and
Oh, 2 pi over
figure it
3,
later and then find an example.
Cosine x is equal to a negative 1/2.
yeah, or negative. Oh, okay, negative 1 was 2 pi over 3.
I can't write it down.
And also.
Okay, do you see where, see, cosine x is equal to a negative 1/2 in 2 pi over 3, right?
Yep.
And where is it the next place?
4 pi over 3.
4 pi over 3. Now then, that's only 2 in that range that this is true, right?
Yeah.
Cosine x equals 1. So, where is that?
It's at 2 pi.
Cosine x is 1. That's
Zero.
that's minus 1.
Plus 1 is 0.
Yep, it's at 0.
Pi.
It's at, no, but you can't count 2 pi, you count 0, so it's at 0.
Yeah.
0 is 359.99.
Okay, so there are your answers in that range. Okay,
This is kind of the same stuff we did 5-2, right?
yeah, kind of.
6-2.
I mean 6-2, right?
24 sine x cosine x equals 1/4. Now, if that were 0 over there, you could do it one way, but now it's 1/4 over there. So what you should look at is, what is an identity that has sine cosine in it? What is sine 2x?
Sin 2x equals 2 sin x cosine x.
Okay, now what would you have to do with this thing to get it like that?
Multiply by
If you did 2 sine x cosine x, what would you have to do to that to get it back to sine x cosine x? Multiply it by 1/2. So now, that thing there, I can write as, I can substitute this in, right? 1/2 sine of 2x. I just modified this so that I could get it this, and then I could substitute that in.
Modifying to where you can get it down to one name, one sine, cosine.
Now, what are we gonna have to do with the 1/2?
Multiply the other side by 2.
Then sine x cosine x, and you roll over there sine 2x.
This is the identity I'm trying to work with.
Made that into an identity and put the
Now,
half
now what
outside it.
what I did is I said, what do I have to do to this to get this thing here?
Half
And
times.
so I did 2 times that, but then I have to take 1/2 of 2 times it to get it back to
We're
here.
gonna do it all at the same time.
Yeah.
Right.
Now then, this thing here, right here, is actually this right here, right? Which is this, and I can substitute that right back down in here.
Where do I get that?
Yeah,
You see,
it makes sense. It's already done.
It makes sense now, but not when you get it home, correct?
and then you have to multiply both sides by 2 to get rid of this 1/2. And now you see I'm ready to do, and notice that the interval that we want that x to be over is what? We're working with 0 to 2 pi, right? But now what we're going to do is we have 2x equals sine inverse of 1/2. So we're going to have to go around how many times? Twice, because we're going to divide it by half, right? Just like last time, we had to go around 3 times because we was dividing it by 3.
It could be
It
just
doesn't
where,
go around.
See, so 2x, the angle for which the sine is 1/2
so
is
when
going to be, what is the first place that you get sine 1/2?
So when we're working with 0,
Okay, pi over 6.
when we're working with 0, we do the, whatchamacallit, and when you have a number on the other side, you gotta do the inverse.
Okay, I'm not listening to you. What's the next place where sine is 1/2?
5 pi over 6.
5 pi over 6. Now, you have to go on past 2 pi, right? And then try the second time around. See, because we're going 2 and we're going to divide everything by half. We're going to bring it back to 1 time around. So then what it is, it's this thing 2 pi added to it, isn't it? Second time around, you're going to add 2 pi to this, correct? So that's 12 pi over 6 you'll add to that. So the next one there is going to be what? 13 pi over 6. Then you have to add 12 pi over 6 to that. And that's 17 pi over 6. Now we've wrapped around it twice, right? And when we get x, we're going to divide it, so we're going to bring it back to 1 time around. See, and what we're trying to do is we're trying to get x. So what we have to do, 2x has got to be twice around, because everything's going to be divided by half, so the second time's around. The first time around is going to be brought back into 0 to pi, right? 1 from here to here. And then the second time around is going to be between pi and,
So if that was a half x, you don't have to go.
then you have to go 4 times around. Because it's going to have to, let's say, it's going to be 4 times it. So then you'd have to go, yeah, you'd have to go half around.
So whatever that, front of that X,
Yeah.
that's how many times you gotta go around,
Yeah.
and you divide it, it'll come back into.
If it was 4, you'd only have to be able to go a fourth the way, because everything would be 4 times as big. If it's 1/2, then you only have to go half around.
Right, that makes sense.
Then, because everything's gonna be multiplied by 2.
Got it,
Here, you have to go twice around because you're dividing everything by 2.
right.
See, this is gonna be 1/2, so this is gonna be pi over 12, right? This is going to be 5 pi over 12. This is going to be 13 pi over 12. And then this is going to be 17 pi over 12.
Yep.
Saying 24 pi would be once completely round, 2 pi, right? Saying if we tried to go the next unit here, we'd go too far. We'd go out of our 2 pi range here. That makes sense? It's this thing right here that has to fall between 0 is less than or equal to x, which is less than 2 pi. That means that this has to go from 0 is less than or equal to x, which is less than or equal to 4 pi. This is 2x, because this is going to be half as big.
Right. That's a better way to look at it.
Yeah.
Everything next to it, like I find it.
I think after you work them, they take a lot of thinking what you're doing.
That's why I can't figure it out.
Yeah.
I finished the fantasy on that, but you got the whole thing on
It's like the satisfaction you get after you get done with it. Okay, this one says 2 square root of 3 cosine of theta over 2 equals minus 3. Okay, what you want to do with this thing is you want to get this cosine pi over 2 or theta over 2 by itself. So you're just going to divide both sides by that, right? This could be a negative 3 over 2 square root of 3. And then what you want to do is rationalize that denominator. So you're going to go square root of 3 over square root of 3. So this is going to be a negative, no, this will be 3 square root of 3 over 2 times 3, right? So that's going to go out. So square root of 3 over 2. So what we have is the cosine 2 equals negative square root of 3 over 2. And notice what we're going to do is we're going to be finding values of theta over 2. So what this is going to have to be is halfway around, right? From 0 to 180 degrees, because we're going to double it.
Oh, yeah.
So where in the range from 0 to 360 or 180, okay, yep, 5, nope, but let's do it in degrees, because it's supposed to be in degrees. Okay, so this is 150. And because see, we're going to multiply it by 2, that thing there is, we only go from 0 to 180, because multiplying everything by 2 is going to get us over to 360. So So this is the answer, theta equals 2 times 150, which is 300. And that's your answer.
And that's 5 pi over 3.
But the only thing is they want the answer
They want
in
it-
degrees. Yeah.
I'm just doing for theta.
Okay.
I like when it's only a half. There you go.
33 says 1 minus sine theta equals cosine 2 theta. What do you think? Is there an identity for cosine 2 theta that will transfer it over to sine theta? Then you'd have all sine. So what would that be? See that this is the identity for that. Now, if I brought this 1 over there, that would make that go away, right? Take this over there, get 0 on this side by itself, I would have 2 sine squared theta minus sine theta equals 0. Can I factor that thing?
Yeah, sine theta.
1 minus sine equals, okay.
Sine theta, 2 sine theta minus 1.
Yeah. Have to take out sine and do it.
Factor the sine.
Oh, yeah.
Now remember, we're dealing on this thing from 0 to 1 to 360. So sine theta equals 0. So theta is 0 in that range. Where's it at?
Up and down. 90 and 20, or 90 and 270. Oh, sine. 90 and 270, right? Or,
Is it at 0 degrees?
oh, we're talking sine.
180. The next place would be 360, but 360 can't be included, right?
Alright.
So the next one is we take 2 sine theta minus 1 equals 0. So this is sine theta equals 1 over 2, right?
Now,
So now theta is half where? I think it's a plus.
30 and 150.
30 degrees and 150. And that's it, right? Those two. Those two. Well, you can solve all of them in degrees and then change it to radians from degrees. Yeah.
I already don't like if there's that many answers for this.
Well, this is what making it that.
No,
See,
like things to have.
if you used your calculator to do this, what would be the value that you get when you do this? Theta equals sine inverse of 0. What would be the one value you get? You'd only get this one, right? Because what is it? It's going to give you values from minus pi over 2 to pi over 2 only. What is the one value you get when you put 1/2 in and go sine inverse?
30.
The 30. If you did sine inverse. So in order, you see, if you were using your calculator and you got something, then and it told you this range to do it, it would only give you this, and you'd have to figure out what this one was. See what I'm saying?
Yeah.
You'd have to understand your unit circle or else your sines curve or whatever it is and know where it's gonna exist again.
Sine and cosine on the calculator only works in 1 and 4 quadrants.
Yeah, 1 and 4.
Right.
Cosine is 1 and 2.
Oh yeah, cosine's 1 and 2.
Tangent's 1 and 4.
Yeah.
Cotangent is 1 and 2. And secant is 1 and 2. And cosecant's 1 and 4. You have to remember all those things because when you're using your calculator, it's going to give you values in that thing. And then if you're asked to find values someplace else, then you got to be able to interpolate it. What?
Pretty fast, no better.
Okay. I'll do 40 because if I don't do 40, it might be a little harder to do the problems that you're going to have to do.
So this is the mother-in-law problem right here?
No.
No, it's the mother-in-law.
Sine theta minus sine 2 theta equals 0. And here, remember, we're going from 0 to 360, not including 360. Yeah, you want to change that double angle to, and what's its equivalent?
2 sine theta cosine theta.
So 2 sine theta cosine theta. And I just put this in brackets so that you recognize that that's that, but really the bracket can be just taken out. I just wanted to make sure that we knew what we were substituting. Now what are you going to do with that? You got 0 by itself, binomial, factor sign, right? Minus 2 cosine. So now we set each one of these factors equal to 0, right? Now, where is it 0 between 0 and 360?
0 and 180.
Now this one, no, its cosine is 1/2.
Oh, yeah.
See, I move this over there, divide by 2, and then I'll just switch sides. Where's that?
It's in the first quarter.
It's what in the first quarter?
60,
60 and
300.
300, yeah, down in the fourth quadrant. It's in the first and fourth. Okay, we got a lot of time left, but I don't want to do any more than this because I know what it'll take. It's going to take a lot of time doing this. I'm sure it'll take a lot of time because you're going to have to use those identities. The thing that you don't want to do is, let's say I saw something that, oh, look on page 282. Here's a typical mistake that this is a typical mistake people will try and do. They would try to do something like cosine 2x equals 4, and then say cosine x. Well, this, I want to change this so that might be a true statement. What's wrong with that? You can't divide inside there. If that 2 were on the outside, if this were 2 cosine x equals 1/2, 1, then you could go cosine x equals 1/2.
Cosine 2x actually equals one of our identities.
Yeah. That's exactly right.
Oh, thanks.
So
for
don't
telling
do that. That's they're telling you on 282, caution, right there.
me. Yeah, we would change that cosine 2x to an identity and then.
Yep, that's what you do. Yeah.
Okay.
And you got those choices. The nice thing is cosine 2x, you got 3 choices for substitution, but cosine sine 2x, you only got the 1. That's
Yeah.
kind of,
I like when there's only one choice.
but only if there's 3, then it gives you a lot of variability that you can work with.
Which is sometimes called hedging.
Same with, yeah, with me, I'm like,
Do you want me to do anything else here? Or do you just want to?
it makes sense. What?
It doesn't make sense.
I'm just gonna go straight home right now and start working on it.
Right.
The only way I'll get it.
Yeah, the only way you get it done is just do it.
So we already have 6.3, right?
Yeah,
You have
already gave us-
6.3?
I got 6.3 at home.
You would have been your Tuesday.
Because I gave them out.
And we kept it too.
I don't know why I think.
What I'm gonna do is, on Tuesday, I'm gonna do that. Let's just look. On Tuesday, I'm gonna do 6.4. And then on Thursday, we're gonna have 2.5 weeks that we're gonna work on 7.1, 7.2, and 7.3. We're gonna have 1, 2, 3, 4, 5 periods.
It's gonna be a hard one.
That's not hard,
Oh, it's not?
but I'm not gonna, what I wanna do is I wanna get all this homework and all this stuff in, because when we do that 7, all you're gonna have is just the worksheets for each section.
So we're not doing 6.4.
We're gonna do 6.4 next Tuesday.
Is 7 gonna be on the final?
Yep,
What?
it's gonna be comprehensive,
Yes.
everything.
One question per chapter.
Are you prepared to sit here for hours with me?
Well, you understand, you know what I'm gonna, just,
Comprehensive's only 200 points, right?